Algebra 1 students, welcome to your 2.8 notes. We're talking about proportions and similar figures on this video. So, there's a couple of key things that we need to talk about as we prepare to discuss proportions and similar figures. The first one, this symbol right here stands for congruent. That means that two things are the exact same. Okay, so you know, if you see this symbol, they are going to be similar to, which means that you could have a couple of shapes that look like they're the same shape, but they might not have the exact same sizes. However, the proportions of those two shapes will be the same. So that's something that that we'll take a look at in this section. And then if you see this symbol right here, we're talking about an angle. Alright, so for number 1, it says the figures in each pair are similar. Identify the corresponding sides and angles. Alright, so what we're going to do on this one, let's zoom to about right there. Okay, what we're going to do on this one is we're going to figure out that angle A, alright, is the same, or it is congruent to angle D. Okay. Alright, so let's take a look at the other angles too, because we've got a couple other ones here. We've got angle B is going to be congruent to angle E. Alright, and we've also got angle C is going to be congruent with angle F. Alright, basically what all that means is this angle here is going to be the exact same measure of an angle as that angle over here with A and D. Same thing with B. Okay, that's going to be the exact same angle measure as angle E. In fact, I think in this one it's showing that it's a right angle, but we don't know that for sure. And then angle C right here, we'll give that 3 lines. Okay, is the exact same angle measure as angle F right here. Okay. The other thing that we know, since these two triangles are similar, we know that the ratio of line AB over line DE is equal to the ratio of line BC over EF. And that ratio is also the same for the line of AC over line DF. And alright, so I went ahead and fixed the name of the trapezoid for problem number 2. We're supposed to say that it's A, B, D, C. With the way that the angles are labeled there. So these trapezoids are a similar set of trapezoids, but they're not the exact same, so these trapezoids are not congruent. But we can say that angle A is congruent with angle E, and we can say that angle B is congruent with angle F. And we can say that angle C is going to be congruent with angle G. And whoops, I need to put my little sign for an angle right there before I say that. Okay, angle G. And then angle D is going to be congruent with angle H. Alright, and I went ahead and put my work in for for basically the ratio of the sides of these trapezoids as well. Here's what we're doing. These lines are represented by the angles here. So basically line AB is this line right here. Alright, and what we're saying there is that the ratio or the relationship between those lines is going to be equivalent to the ratio between these lines right here. Okay, and so on and so forth all the way around that trapezoid. So that's what we're up to when we discuss those ratios. Okay, and we're going to discuss in the next couple of problems how we can take that and use it. Alright, so my figures didn't show up here, so I went ahead and drew them for you. On your notes, you can draw them as well. You might need to pause the video to do that. So right now might be a good time to pause the video so you could draw the triangles and the parallelograms that are missing from your notes. But I'm going to keep going. Here we go. What we can do in order to figure out what the missing side length is we can set up a ratio. We know that the triangles or the parallelograms are similar because they give us that information right here. Sorry if you can hear the thunderstorm in the background. There's always something going on in the background when I make a video. It never fails. So here we go. We're going to set up a ratio that side length 3/2 is equal to the side length ratio of x over 1. As long as you use the same similar side lengths, okay, per triangle in the similar spot on your ratio, you should be fine. And then here's what we're going to do next. We're going to use our cross product property to multiply these puppies and actually figure out what we're going to come up with. So we should have in our next step 2x is equal to 3 times 1. Alright, and we know that in algebra that's basically 3. We can divide both sides by 2. Alright, and we'll have that the missing side length is x is equal to, oh, come on pen, 3/2. Okay, so that's what we get for our missing side length in number 3. And I forgot to put a number for number 4. We're going to do something really similar in problem number 4 because we're going to set up another ratio that's equal to each other. So here we go. On this one we're going to go x over 10 is equal to 2 over 5. Right? That proportion, that ratio is going to be the same. We're going to use our cross product property. Let's go ahead and multiply across like this. And we will have 10 times 2 is equal to 5x. We know that 10 times 2 is 20 is equal to 5x. Let's change colors. Divide both sides by 5. We're going to end up with x is equal to 4. So our missing side length in the parallelogram is going to be 4. Alright, so in number 5 it says that the scale of a map is 1 centimeter to 15 kilometers. Find the actual distance corresponding to each map distance. So we have been given that information, 15 kilometers, alright, is equal to 1 centimeter. Okay, let's go ahead and set up our proportion as x kilometers, we don't know how many kilometers we're going to have, is equal to 2 centimeters. So when we use our when we set this up and we use our cross product property here, this is how we figure out what the missing distance is going to be in kilometers. So we end up with 15 times 0.2 is equal to some sort of a distance in kilometers. Alright, when we multiply that out in our calculator, we end up with 3 kilometers.
Okay. We've got a similar situation on this one. Basically, we were going to have the same ratio. We've got 15 kilometers. Okay. And that's basically on a map that's 1 centimeter equals 15 kilometers. And in this case, the distance on the map is some sort of kilometer distance for 4.6 centimeters. Okay, so it's basically the same setup, right? We're going to have 15 times 4.6, and that's going to give us whatever our distance is. In kilometers, we already figured that out. I'm going to go ahead and pause it so I can calculate that for you. And there you have it. It's going to be 69 kilometers, okay? So, let's move on to number 7. Alright, we have Happyville and Smallville. They're 155 miles apart on the map. The distance between the two towns is 2.5 inches. What is the scale of the map? Alright, so this one, what we're going to do is we're basically applying this information, and we basically want the scale to be some sort of an inch property. So basically we're going to take 155 and divide it by 2.5. The answer is going to give us what our scale is. So I'm going to pause it so I can do that calculation. Alright, so I came up with 62 miles is going to be equal to 1 inch. And I also want to kind of add in one little thing to our notes today. What I want you to do is right after you're done with number 7, I just want you to take your pen, just like I did when I was doodling, and just kind of take it and make yourself a little swirl, kind of like this, just for a little bit. Just make a little swirl on your notes, just like this. And when you get to class, what I want you to do is just go ahead and show me the little swirl. I'm kind of curious who actually took their notes by watching the video. And I'm kind of curious who is taking their notes by copying off of their friends' set of notes. So, don't tell your friends if they didn't watch the video. And don't let them copy your notes, but just take your notes and do a little swirl. And enjoy the rest of the song.